Elder, and I will be your guide really for today. So today, what we'll literally be doing is to um really for those that don't have Flow yet or Fork Orchestrator yet, install the Fork Orchestrator and write our very first smart contract. The idea with doing this is to do something simple one, then also be able to learn as we write, as we build. So you get familiar with, for people who already have a bit of background, you know, writing programming languages becomes easier. So you just learn the syntax at the same time, build something simple. So we'll do that and then we'll deploy to testnet. And then we should pause the class for that for today. Then at that time we'll come back to, test our contract and build more cooler stuff. All right. So I just sent the link to the chat. Let me resend it. I don't know. Okay, yeah. I just sent a link to the chat for people who don't have fork installed yet. I believe you need Rust on your system. I'm not quite sure. I don't remember. But you need to run this command on your terminal. So once you run this call command, right, it automatically installs the fork orchestrator for you. FORC, the fork orchestrator, right? So that's what we're definitely gonna use. I don't know if I should give you guys like a minute or two or some seconds to do that, or I just go on. But if you follow the docs right down, you'd follow the instructions where we can do the foil updates and then use the latest version of fork. Let me ask it. I can should I wait for you to do that or should I proceed?
So can you hear me?
Yeah, I can hear you now.
Okay. If since it's on the docs and it's not going to take me time, you can proceed while I'm doing the installation. Since we are not coding yet, while you are talking.
Okay, okay, sweet, sweet, sweet. So once you're done with this, right, we are gonna like create our very first. I'm gonna follow this doc to a point, right? Talk about the example, and then we go to my own project and why I chose to build this for our own very first example. All right, sweet. So after we've done, after you've done installing the fork orchestrator, right? Then the first thing we want to do is to create our very first new contract. And let me share my terminal. All right. So once you have fork, I believe you should have something like this once you run the fork orchestrator, right? This shows you that you already have it installed. And you can check your version. I'm currently using, I don't know if this is the latest really. I've had this for a while. But I'm currently using 0.66.4. And yeah, so what we're going to do now is we're going to create a new project. Really, if you look at the instructions here, you literally already see that if you want to create a new fork project, you need to create fork new and probably you know, your project name. So simply like almost same way Foundry works, right? So let's create a first class, right? So for us, we'll create our first fork new first class. All right, let me see if this is there. Yeah, we can see our first class there, and I am going to open that with VS Code. Sweet. All right. All right. Great, great, great. All right. So one more thing, right, for you guys following along. if you're using VS Code or Cursor, I use both actually. So come to your extension and install. Although you could also find the code right on the docs, but you need to install the Swaylang, extension so that you have a bit of formatting, right? So you don't write, you don't go writing gibberish so fast, right? So once you install the Swaylang, extension, you have your Sway contract looking like so. Cool. All right. So, like I said, this is just a very mock and very simple contract right here, and I'm going to explain what this does, right? And then we'll build something cool, in my opinion, of cool, right? All right, sweet. So, I'm going to maybe for people who have a bit of Solidity background, I think that I'm going to be doing a bit of compare and contrast so that you can easily match up, right? So in Sway, for instance, when you're writing a contract, you declare it with this contract keyword. So you declare that okay, this is a contract. If it was a library, you would declare that hey, this is a this is a library, and stuff like that. So we declare that telling this way, that okay, we are writing a contract and we start with the contract keyword. All right, so it knows that all right, I'm going to be thinking about this code base really as a contract. And then we have ABI. Think of this ABI. I know that for people coming from the Solidity background, ABI really is still the same thing. It's a list of button. Solidity is like a JSON file that contains a list of functions, errors, and literally a mock-up of what your contract looks like. But here, think about ABI like your interface, right? So it contains a list of functions that we want to implement. All right. So if my API has this contract now is called my contract for some weird reason, right? But yeah, since it's a mock, right? So since my API is taking just one function, test function, my contract is also going to take it. So if I decide to implement maybe a function, another function, right, the code base begins to scream because I did not implement this function right in the contract. So yeah, that's how it works. So you have like an interface here, and then you now begin to implement for your contract. Pretty straightforward, pretty simple, very, very cool. So yeah, do you have any questions right now before we go ahead? Let me check my browser. No questions now, no. All right, cool.
I
Let's
want
do
to
it.
ask something. Does it allow um like use of like error handler like that to
Yes,
handle?
yes, yes. By the time we go to more um advanced, no, we could use in Solidity, right? You can have. Why is my browser not wanting to minimize a window? Oh dear. Hold on. Yeah, so anyway, let me answer your question. So in Solidity you can have a require statement, right? And your require statements can take your instruction and a string literal, right? So you
Okay.
can say require that message or sender is this person else, or message and sender is not. So you could just put the very straight up string there, or you could also use custom errors, right? So with Sway too, you can also have custom errors. You can have just a direct, it's literally almost the same thing when it comes to that part. No too much difference. A lot of things are still the same, like your block height, your timestamp for people coming from a Solidity background, right? You know, yeah. So yeah, it actually does. You can also like implement, specific errors.
Awesome.
How does
Thank you.
Yep, yep, thank you. So I'm trying to go back to my browser. Don't know why it's acting so weird. Sorry, hold on. I'm trying to I'm trying to minimize the browser. It's acting weird. Weird, 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 weird. 1 second. All right, sweet. I'm back. Sorry for the technical glitch. All right, cool. So, yeah, so this is literally like a basic contract, test function, whatnot, returning boolean, right? Test function returning boolean, and yeah, return true. For people that are familiar with trust, you know, you can actually do this too, right, or whatnot. I believe. All right, cool. So yeah, so Swale almost looks like Rust, right? But it still carry that stability mindset. Just looks like Rust, but stability mindset. It's actually pretty cool. All right, so the contract we'll be doing today, we'll be doing a very minimalistic or a basic, um, a basic uh voting contract, right? So we in my country we have the elections coming in like 2 years time, but we're already campaigning, right? So why not like since fuel has a very large CPS, why don't we like build a voting contract for people? And what we're going to do is we're going to have, I think in our voting contract we should have a function where people can vote, right? Ah, damn. Then we should have a function where people can maybe view their results, something like that, right? Then we should have a function where we can create votes, right? And I think these are the three. What other function do we need when we are creating a voting contract? Um, yeah, view the winner. We can create. Oh yeah. We should be able to create a voting ID. Create a voting ID, something like that. ID. But not. All right. So, like I said, please, if you have any question, feel free to ask me. I don't think I've gone anywhere deep yet, so you never can say, right? So the first thing we're gonna do is to declare, hey, we want to write a contract and sweet. All right, cool. Then the next thing we're gonna do is to use where Sway has some standards, right? Standards such as timestamp, different type of variable types or yeah, stuff like that. I would let me check the doc so I can also share that so it doesn't look like I'm performing some magic somewhere. Um, Hold on, please. See if I have that here. Okay, so we have this free standard library. I'll be sending that to the comment section now. Okay, cool. So you can have, you can see what I'm doing and I'm not like mass producing it, and stuff like that. So back to where I was. So yeah, so we need to use some of the standards, right? We need to use the one for to get the timestamp. We need to get, for bytes. We need to get for U256 and whatnot and whatnot. So the first thing we're going to do is we're going to create a struct, right? Where is my code? What is this the future where we are going right now? I can't even write a single thing, right? All right, so we're gonna create a struct vote info, right? And it's gonna contain the following rather than so we have our vote info will contain a unique ID. Then it's going to contain the username and the count. This is the vote count. So the idea is that, hey, the unique ID is okay, each participant that is voting. Say if we are having an election now, each participant should have a unique ID as well as their name because I believe some people might have the same name, you know. And so the unique ID helps us differentiate what person or what person, right? And we can also have a count. When somebody votes, it increases the number of votes that that participant has had. All right. So now we have created a struct. Oh dear. Then the next thing we're going to do is how do we store? Because in Solidity, you could do something like this, right? You could do something like this, and then you just keep writing, and your storage is, and you're storing directly on on that particular slot. But here, what we'll do is we actually have to define a storage keyword like this, and then now everything that is put within this is going to be stored in the storage slot. It's going to be stored on the storage. So you can't have it just anyhow, like so this way you just put mapping and put arrays wherever you like. Here, every group of variable is going to be stored within the storage. All right, cool. So now what are we going to store? If you have any questions so far, please let me know. If you have any questions so far, please let me know. So the first thing we're going to store is the voter's ID. So we're going to store the vote ID, and this vote ID is going to be, say, if we have three different elections going on. So the first election can be like vote ID zero, the second one can be one, can be two, so that you know, okay, I am voting. You get the logic, right? So I'm voting for maybe this particular. So everything is not just all clashed together. And the second thing we're going to need to do is to create a mapping, right? So we're going to have a mapping for vote ID to to this participant. All right. So how then do we do a mapping? Like I said, we're learning as we're building. Okay. So how then do we do a mapping in on Sway? On Sway, we use something called storage map, like so. So, oh dear, why scream it down? Could not find storage vector. Interesting. 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 We need to import that from one of our standards. All right, sweet. Wait, I hope you guys are seeing my screen really comfortably, right? You guys with me here? All right, sweet. All right,
Yeah.
so yeah, so this is literally it. We've initiated what we've created. We're having just two things stored on the storage: our voting ID per election, or per election. Yeah, that makes more sense. Or you could have maybe different states. So Lagos State could have voting ID zero, or local government Lagos State, or whatever, and or whatever nationality, right? So by that ID, you can tell, okay, these are people that are participating in this. So that automatically. So this is literally done. Then the next thing we're gonna do, remember our contract is to create our API. Dude, I don't what AI is this? All right. So it's to create our API. So I'm going to call it our contract, the voting contract, right? Let me not do that. All right. So, okay, cool. So now, once this is done, I don't think I actually remember seeing that. But anyway, when we're creating here now, remember this ABI is like an interface where we define our functions, right? So we'll also need to define their visibility. So for instance, in Solidity, if you want a contract to read only from storage, right? You just call it a view function, right? Same here. So if you want it to be able to write to storage, you could either make it public or external, depending on the case, right? So here, if we know, okay, I'm trying to, maybe let's say I have a function like so. Let's, dude. So let's say I have a function like so. Create function, create vote. Obviously, this is going to be a function where I'm going to have to be writing to storage, right? And so what we're going to do is we're going to declare it. And to declare it is pretty easy. This is how we declare. So it tells it that, all right, this particular function will be reading from storage. This particular function will be writing from storage. I'm going to take it bit by bit because you know the way this ABI works. Once I try to implement a contract and I don't write out the whole function, it starts screaming. So first to the create vote. Maybe we are INEC. I'm hearing the sound. What's that? All right.
People are
So
join-
oh dear.
people are joining the.
Um, I hope they don't get confused, right? Anyway.
They will follow up from. They will watch the record,
Okay. Okay, cool, cool,
and if
cool.
they have any
So
question, they can.
yeah, okay, that sounds cool. All right, so let me remove this guy so this code becomes clear. All right, so yeah, we're actually working on a single voting contract, right? And so now we're talking about our first function to create votes. This is a mindset that all right, in Nigeria, if you're in Nigeria, right, this is INEC, and you're the one in charge of you know creating all the ballots, whatnot that people are going to vote with, right? So we're going to do this, right? So the first thing we're going to do is to implement voting contract. Oh dear, for contract. I believe this should be capital letter C. Here we go. You know why it's screaming here? Functions missing. We've not done the create, vote, whatnot. So I'm just gonna copy this stuff here. Okay, yeah. So when you are writing the contract as well, you also have to indicate. So basically, we're taking votes that all right, this in this implementation, this is actually like so, and oh dear, you should return a U256. All right, let me just put one for now. So it stops making noise. All right, cool. So what are we doing now? We are want to create a vote really. So we are going to do this. So now we're going to learn how to write to storage and how to read from storage. So cool. So the first thing we want to do is get the current time because ideally every time an election happens or you're voting for a particular thing, there should actually be. I did not actually add that here, did I? Huh, interesting. Huh. Well, that's a bug. I hope somebody comes to fix it anyway. All right. So ideally, for every election, right, you have like, oh, this election is going to last for the next 12 hours and whatnot and whatnot. So we're supposed to have that info, like, all right, this election or whatnot start last for like, you know, damn it, I did not put that in the code. So this is how you get your timestamp in for in Solidity. You will most likely do something like lot of timestamp, I believe. But here, yes, this is something like in Solidity, right? But here you just, call the timestamp function, which you imported from the standard library. Cool. And if vote ends is less than current time panic, blah 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 blah. Instead, I like this. What I'm going to do is that I'm going to use the require. So I'm going to say require, dude, calm down. So I'm going to say require uh, that vote ends. No. All right. So I'm going to require vote end to be less than, that is the, no. Yes. Of course, that makes sense. Right. Then if it's not so, you can say, okay, the vote end time must be in the future. Because, all right, vote end is U256. Current time is in U64, I believe. So I'm going to just do this. Yeah, sweet. Any questions? No? Cool. I hope I'm not getting you guys lost yet. All right. Cool. So the next thing we want to do is with creating a vote, right? Ideally, we're supposed to have this um timestamp somewhere in our storage, but I didn't have it, so I'm going to create an extra variable, an extra mapping, really, and it's going to be, let me call it vote timeout, right? And it's going to be a storage map of storage mapping is mapping, right? Storage vector is like a vector where you can store on storage. All right. So we're going to do, I want to do a storage map of, thank you. Yes, this is what I want to do. Storage map of the vote ID to the timeout so that we can know that, okay, oh, people don't keep voting beyond the, when the time has elapsed. Right. Sweet. So now we're going to write. So this is our very first vote, really. So the first thing we're going to do is to read this, something like this. So we're going to say, uh, let let me say current. Please, if you have any questions, let me know. So we go storage dot read. Nope, storage dot votes ID. All right. So this is how I access this dude here. So now I've read it. If I want to write, it means I will write storage dot vote ID dot write. Well, now I'm reading, so I'm getting it that was there before, and I am going to add one in code, so that's, incrementally and stuff like that, and then we create our very first vote. Jeez. All right, cool, cool. Guys are still here. All right. Uh, so the next thing we're gonna do is to do like this: storage dot vote ID dot write. Nope. Please, this AI should not confuse me. So, all right. So we are increasing. So we read. So the first thing we're doing, we're reading the current source. So we're imagining that right now this is actually zero, right? And we can give our first vote ID zero. We can make it one. Doesn't really matter. Let's assume the first one will be zero. So we'll start from zero. So we don't skip the first one anyway. So once that is zero, the first thing we're going to do now is to create the timeout, a vote timeout. So we need to write to the timeout. So to write to the timeout, to say storage, dude, storage dot vote. This is the this is the this is the future of writing code. So we're gonna write, and what are we even writing here? Oh, we're gonna insert, no? Yes. Hold on. We're gonna insert actually because it's a mapping. So we're gonna insert uh-huh U256 to U256. So we're gonna insert current vote ID like so to votants. Yep. Yep. And once we've done that, we're going to write. So now we've gotten our vote ID. Our vote ID initially zero. So for vote zero, we are saying that, oh, the vote ends at maybe in the next 12 hours, or whatever that timestamp is, right? And then we now increase our vote ID by one. So once we do that, we can just return this instead of returning one. And there goes our create vote function as we are INEC. Ideally, right, you would expect that since it's not everybody that should be able to create votes. We're not making it fully decentralized, or let's assume we're making it fully decentralized. But since ideally, I'm supposed to have a required statement that does not just allow anybody come here to just create. Now, depending on the use case of this contract, but here we're just opening it that, oh, anybody can come here to create a vote, right? But you could also have it like, okay, this particular address, but because I'm not going to address today, I'm intentionally not putting that particular feature here, because when it comes to addresses, assets ID, and all that's a bit different info. All right, cool. So now we've created our vote. So the next thing we want to do is to create a function to create a contestant. So somebody who is, so we have a vote, our vote ID zero. People who are voting maybe in Lagos State, for instance, they created the vote, the ID is zero. So me as a participant in who want to campaign will go and register under that ID. And that function, we're going to call it a create contestant, kind of vote, kind of a thing. So, right. So the first thing we'll first do is to go back to our ABI, and then remember, because it's going to be read and write function, it has to, we declare it like so. Cool. It's screaming because we need to implement it. All right. So we're saying, okay, create a contestant. This particular place will be your vote ID, the ID of the vote you want to like join in, and then you'll be passing in your username. So if Mayowa, for instance, or First Elder, for instance, or Esther, for instance, or Akan, for instance, wanted to participate in an election where they are campaigning for Web3, I don't know, we'll all go to create our contestant, create as contestants under that particular ID. All right. Cool. So now we do the same thing here. We come here, and I'm just going to put one here so it clears out the error. All right, cool. So we're going to create a contestant. Sweet. So to create a contestant, literally what we're doing now is just get the ID. We have the ID, right? And we're just going to store the person into this vote info storage. Literally just push the individual here, and that's just literally it, right? Cool. Any questions so far, though? No questions. Cool. All right. So the first thing we're gonna do is um, get the vote ID, right? So this one is just to prevent somebody from manipulating the system. So if there's only two vote ID and somebody saying wants to vote in vote ID three, just say, hey, that vote ID doesn't exist. Ideally, we should also check that the voting has ended right before. So Ego, remember your question where you can have errors. These are the errors, or you could also have custom errors. So let me put another one here. So I want to check that when you're creating a contestant, right, the voting period hasn't ended. And to do that, we do require that storage dot votes. Ooh, okay. Let's see. I hope I'm not gonna make a mistake. Dot. So we are getting an ID, right? If we're gonna unwrap this, no, no, oh dear, hold on. All right, yeah, that is true. So when you're trying to get data from a mapping, you use the get keyword, right? And yeah, that works. So no method gets storage due to 56 greater than equals to boolean. Question. Does somebody have a question? Huh? No. No. All right, cool. All right. Where was I? So what's this guy saying? What's this dude saying? Greeted, blah 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 blah. Why now? Why scream it down? Why scream it down? scream it down. All right. Hope I haven't got anyone lost. All right, sweet. So good. So we were checking that. All right. Hey, uh, this particular voting period has ended. You can't create a contestant anymore. All right. Cool. So the next thing we're gonna do now is to now create the contestant. Great, 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 great. So to create a new vote ID, we're just gonna create our struct. I think I'm only using more than an hour. So we have a new vote info. Um, unique ID. Hmm. Yeah. Yep. So this unique ID, what we're gonna do? Oh my god, let's do this. That's what I want to do. A nice cream. Please clean it. All right. So this unique ID, what we're going to use for the unique ID is to get the length of the array. So for instance, if one participant comes in, his unique ID will be zero. Then once there are two people contestants, the unique ID becomes one. And stuff like that. So I intend to use the all. Yes, I intend to use the length of the array. So one, two, three, actually, rather than zero. So I will need to get how how large this storage vector is, right? And to do that, so I'm going to do this. All right. So I go to the vote storage dot votes infos. Then I get the ID, this particular ID that this person is trying to join. Then I just get the length because it returns for me a storage vector. So I just get the length and then that becomes my unique ID. Then the next thing I'm going to do is to write. I will need to write to this particular or push, right? Yes, I'm going to push because this is an array. Sorry, this is yeah, the vector. So we're going to push to it, then write back to storage. And that's what you're doing. All right, so vote dot push new vote info. Okay, cool. Then we're going to write back. I hope this guy gets it. Uh-huh. All right. So once we've done this now, and so now what we've done is we've created the contestants, right? We've got the number of lengths of people that are participating in that election already. Then we use that as their unique ID. So once the person creates a creates or they add themselves as a contestant, we expect to return their unique ID to them. So it is the unique ID we're returning here back to them. Cool. So now we've created two particular functions in Sway already. So the next one we want to do is actually vote. Then we'll see the results. Dude, any questions right now? Let me check. MJ, Debbie, hi. Any questions?
Please, can you feel free to ask question. That's why we are here. Ask question wherever you feel you're confused. It's going to throw more light on it for you.
Mm-hmm. All right, cool. I guess no. I guess no. Okay. Yeah. So yeah, we created a contestant, right? And so the next thing we want to do is to create a function to vote. Create a function to vote. Let's do this quickly. So we go back to our ABI, right? Ideally, you could all write this down like completely and then, but I don't want there to be so many red lines. So we're creating a function to vote. Of course, if you want to vote, you literally just need the participant ID, that person's unique ID. Oh dear. and the vote ID. So yeah, I know, right? I know. Oh dear. All right. So since it's a read and write, come here back, do this stuff. Wow. You mean if I do all this, you'll be correct? Let me try it and see. I'm like, it's not gonna work. All right, sweet. So now we want to vote, right? So want to vote, we'll need to get to storage mapping. Get the arrays, the array rather, or the storage vector of all the data of all the participants. Look for the one that matches the unique ID that we want, and then we vote. So once we are done, when we are done with that, it should return the name of the person we voted for. So we are sure, okay, this is the individual we voted for. All right, sweet. Question? No. Cool. All right, sweet, sweet, sweet. All right. But then this function is actually long. I'm actually going to do copy and paste here because it's actually a bit long function, right? But it's simply, I would explain it really. So that we can be faster. So I did past 12. All right. Okay. So let me take it bit by bit. So you see what I actually did here. Cool. So the first thing I did was to get the votes ID. So for the vote now, like I said, we went to the storage. It's almost the same thing I did here, right? I just got the voter ID. All right. I mean, what are the data that are available in this particular vote, and then I just verify that, oh, this particular contestant is valid using this their unique ID. Now the next time I'm going to do is, which I did not add. I'm going to actually add that, yes, that all right, this vote is not, hasn't ended yet, right? And I'm just really going to copy this function, this line, and add it here, so you don't vote when you know get vote ID. All right, cool. And yep, so that is that. Then the next thing I did was to get the username, because the username, if you noticed, I've been using a bit 56 for to store my username in the storage, right? You can't actually store strings directly. So yeah, and this particular conversion comes from one of the Swiss standards, right? And I'll be importing that now. Please, if you have any questions, let me know. Let me know. Let me know. All right, cool. So yeah, that's that. So yeah, I've gotten the user. What's this? I declared an empty username actually because I want to return the username to the person that votes, because they are passing their unique ID, right? But once they have voted, I want to be able to see that, all right, it is the first day that I'm voting for. It is this person, particular person I voted for, right? And so now the next we're gonna do, which in Solidity most times this is gonna cost you like quite a number of gas, right? Because you're using a loop in a function, right? But that's what we're going to use here. So it's what we'll do is to go through all the, all go through the vector and look for the unique ID that matches the one this individual wants to vote for, and then increase their vote count, Cool. So which is what I'm doing right here. I'm going to share this code base, right? So you can actually come back to like go through it one at a time. All right, so this is actually what I'm doing here. So I went through, okay, go through all the votes, then, get me, once you find the one that matches my unique ID, increase the count, and then, update that data on that array and then write it back. So literally that's straightforward. Um yeah. So the next thing we're gonna do really is to last hide right like the last function, which is to view our winner. So we can view the winner in real time while the vote is going on and also after the vote has ended really. All right, so we just have that now because the view winner is not you're not necessarily going to be writing to storage. You're only going to be reading, which means our ABI is going to take only the read function and we're going to have something like so. You there. Uh-huh. Let me see if don't know. All right. So yeah, so to view the winner, like I said, dude, hell no. So yeah, to view the winner, right, we just get you just give me the unique ID or you give the contract unique ID. All right, I participated in maybe unique ID two. That's the election type or whatnot. We could actually use a better thing than just numbers, so it makes it a bit more generic anyway. And then you could just find out who's currently winning or who won. And you know it's actually on chain, so the data is never really compromised. Not like I'm not going to mention that. Either way, all right, cool. Yeah, so we're going to create a view function to check our winner. And I'm also going to just copy and paste that because it's literally just repetition for the first one. Similarly, it's actually almost the same thing. All right, so let me explain what I did. So first thing I did was to get the ID. Okay, this is the ID I'm currently working it. Then require that all right, people actually voted in this ID. Then then I decided to like try to get who the winner is by going through this while loop and then trying to find the one with the highest votes. This algorithm helps us get the one with the highest votes. So it first starts from the first person. It assigns the first person as to the first person is the one who won the election. Then it starts trying to check. Once it finds somebody whose name is whose count is higher than that, it updates the person, you know, as the current winner. All right. And this is literally a very simple, straightforward voting contract. Um, it's minimalistic, right? There's not too much advanced stuff in it, in my opinion. All right. And yeah, so this is how a sway contract looks like. Simple sway contract looks like. And over time, maybe once we start going into more advanced stuff, we could actually remove a lot of things from here. So I could have the ABI abstracted out. I could have my errors abstracted out. I could have other things abstracted. So this just takes this particular main dot switch just takes, the main implementation. All right. And that gives us like a more like, professional looking kind of code base, really. Cool. So the next thing we're going to do on our any questions I actually at this point before I continue. A question. Cool, cool, cool. So the next thing I'm gonna do is the next we're gonna do, which is the last thing for itinerary today because I didn't actually get to spend an hour, so I was rushing. Is to deploy. How do we deploy to testnet on for all right. So for people who are familiar with Foundry, yeah, yeah, it's a command line and whatnot, but it's actually pretty cool than hard hat, right? But it's actually way simpler on for like super simple. And I'm going to show you an example right now. So yeah, I should actually have run fork build, so it doesn't look like but I know that it's gonna build anyway. If it doesn't have to worry. All right, so yeah, I built the contract, right? You can also do something like this fork format if you want to. So I've formatted so it doesn't look so much strange. And now we're going to deploy our very first year um, for for contract to the testnet. How do we do this? To deploy it, you just go fork test deploy. Hope I remember this command quite well. Oh yeah. Shit. Hide. Sorry. Oh, the. Is that a question? No. Okay, cool. All right. I think this is where I'm working on. First class. Cool. Let me check. Um, fork. All right. All right. So it's fork test deploy. So you're deploying to your testnet. Fork test deploy. Sorry. Uh, that's. Oh, what the hell? Fork Fork deploy testnet. Jeez. Fork deploy test. Please, I take my former statement back. Fork deploy testnet, right? So you deploy and you just indicate the flag. Yeah, that makes a lot of sense. And I click on enter. It does all the magic for me. Um, yeah, and my wallet password. Actually, I think we did this particular creating of four wallets. I'm not pretty quite sure. We did it in like a previous session, right? But if you actually have any issues, please reach out to me. It's actually pretty simple as well if you check the docs. Now to create a four wallet like locally, right? And I'm just going to input my password. And do I want to sign this transaction? Of course. Oh dear. Look at the wheel, right? There. And that's literally it. Our contract has been deployed. We can view it
I think
here.
I love this. It's very quite easy to deploy
Yeah,
with
it's
um,
straightforward. It's super
straightforward.
straight. Yes, it's
Don't
super
need
straight.
so many commands to do.
No, no,
Wow.
no. So let me share my our contract. Our very first. Let me look for the window. All right, cool. And here is our very first contract. So this is our contract address. We're not minting any asset or whatnot and whatnot. And then our byte code. So this is why foil is it's actually pretty really cool. I think it's like one of the, as far as I know of, one of the fastest or easiest to learn, aside from Solidity, right? For people who already have Rust background, a bit, and yeah. So this is literally it. We covered a bit installation. We did a bit of a very first four contract, and then we deployed on our very first testing. So this is how well Explorer looks like anyway for people just seeing it. All right, cool. So yeah, this is what we're posting for today. Next time we'll be writing a test to verify the if we, because now it's a we thing, if we did rubbish and our voting contract looks like trash. So yeah, feel free, please, if you have any question, let me know. But this will be posting the class for today. The next time will be coming, and the next time I think for people who may not necessarily like have any foundation in Rust at all, I think maybe we should like go through the docs a bit because we can already test both in Sway. I personally prefer to write it in Rust, kind of more verbose, like I said before. So, but I could try if we should write it in both Sway, and it might actually be simple, because the language itself is simple, writing the test, but it just really clicked for me, you know, writing it in Rust. So, yeah, any questions? Pretty cool. This is where we'll be posting it for today. Let me not take too much of our time. And thank you so much, guys. Thank you for attending. Thank you for being a part of today's session. If you have any questions, you can reach out to the Foil Africa account on Twitter. You can also reach out to me on Twitter at First Elder. And yeah, thank you. Any questions? I'm here. There you go. That's the
All right. Thank you, First Elder, for this amazing workshop. And we love to have you more. And for our audience and for people that are going to be watching this video, this recording after now, Um, you are highly welcome. Look forward to more workshops as we'll be doing more on fuel and swing. So, if you have any question, you can come to our Telegram channel or fuel Discord. Tag First Elder, tag me. Come to our Telegram channel. Ask any question. Wherever you are stuck, ask First Elder is available. Come to the Telegram channel is very very easy to for you to discuss with him and ask your question, and he can easily respond to you. So you are all welcome. Catch you more next time. So we'll be sharing more updates. If you are not yet in our Discord channel, kindly our Telegram channel, kindly join, and also join Well Network Discord channel. Thank you. All right, see you
Thank you
next
so much, guys. See you
time.
guys. If you have any questions, please reach out. Thank you, Esther. Thank you so
You're
much.
welcome. Bye.
All right. Bye, guys.